Physics, Chapter 21, Theory Video 2. Write down the note. Electric charge results in following phenomena. Number one, it produces an attraction or repulsion depending on the type of charge. Number two, it can result in an attraction to an uncharged object, within brackets write electrostatic induction. This charge develops because when two surfaces are rubbed against each other, one material loses electrons to another. The material that gains electrons would be negatively charged, whereas the one which loses electrons would be positively charged. This process is known as electrostatic induction. Next one. Around a charge, there is an electric field. This can be observed in two simple ways. Number one, leave a line and write number one. Placing a charged strip of gold foil attached to an insulating handle in between two charged plates. The foil will bend towards the opposing charge. Number two, using grains of material such as semolina, 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 which gets lined up in an electric field just like iron filings would line up in a magnetic field. The electric field is a field of force because it does work just like a magnetic field or the gravitational field. Electric fields can be represented by field lines, within brackets lines of force, and can be represented as follows. Please draw these A, B, and C diagrams and write the 2 points that are given here. I will read out the points for you to write down. A uniform field has the same strength at all points. Example, the electric field between oppositely charged parallel plates. The electric field between oppositely charged parallel plates. Number 2, a radial field spreads outwards in all directions. Example, a point charge or a charge sphere. I hope you understood, and I'm sure you have done question number 1, 2, and 3. Now I'm going to move on to electric field strength. So let me explain what electric field strength is first. It can be defined as the force per unit charge exerted on a stationary positive charge at that point. Electric field strength is defined as the force per unit charge exerted on a stationary positive charge at that point. So we are talking about the unit charge here, right? So around the charge only this field strength is considered. So then we imagine putting a positive test charge plus Q on a field and measuring the electric force that it feels. So here in this diagram we can see the positive Q charge in the field. So the force that it feels is what we are trying to measure. So we have to use a positive test charge because that will actually give us the direction of the electric field, right? If you when you use a charged gold leaf, what happens is we test the field with using a charge. That is exactly what is happening here. It's the similar concept. Now from the equation we can use, now in the definition we said force per unit charge exerted on a stationary positive charge at that point. So then from that we can write an equation for E. E equals F upon Q. E is the electric field strength, we have met that earlier. F is the force and charge is Q, right? Charge, F is the force on the charge and Q is obviously the charge. So then from here we can take the units of the electric field strength, newtons per coulomb, because charge is underneath that, force is above, newtons per coulomb. Then E equals F over Q is an equation that you need to remember. Then when we get the equation into consideration, there are other factors that can be related to this. Now what we do is we take two parallel metal plates and then we connect it to a high voltage power supply, right? Then we realize that there are two factors that will define or that will decide the strength of the field. The first one is the voltage V between the plates. If there is a very high voltage, higher the voltage, the strength of the field is also high. So that means the field strength E is directly proportional to V. Higher the voltage, higher is E. Then separation D between plates. So obviously you know if the separation is higher, the field is going to be lesser. We learnt about it earlier. Then E is inversely proportional to D. That means E is directly proportional to 1 upon D. Right? So then we combine these two factors and get another equation, E equals negative Vd, negative V upon d. Right? Now we usually omit this negative sign because we actually we are not really interested in the direction of the field, but only the magnitude. So we can actually eliminate that. Then we realize that E is a vector quantity, because when the voltage V increases towards the right, the force would act in the opposite direction towards the left. Right? So that is also something that you need to remember here. Then the equation for strength of a uniform field between two parallel metal plates, E equals delta V divided by delta D. V is voltage, D is separation. So that is another equation that you need to remember. Right. Now in this equation, the real photograph of real picture of what we discussed earlier is given here. So D is the separation, and then to the left you have the field lines, right? So what happens is, when the voltage increases towards the right, then what happens is the F would act in opposite direction towards the left. Therefore, E is going to be a vector quantity. That is the relationship. So remember, E is a vector quantity. Now, this formula also gives us another detail that shows us that electric field is equal to the change in potential difference divided by the change in distance. Right? So that is, E is negative delta V upon delta D. Right? So delta means change of. So that is the definition of earlier equation. So then we can take the units of electric field strength to be volts per meter, because here delta V upon delta D. Volts is the voltage is measured in volts, distance is in meters. Then we get 1 Vm minus 1 is equal to 1 newtons per coulomb. So these two are equal in value. So now let's go through this worked example to see how this calculation can be done. So these questions you must practice over and over again, because that is going to be a part of your examination for sure. Two metal plates are separated by a distance d. So the moment that you hear this, you know that you can use the delta V upon delta D equation. The potential difference between the plates is V. A positive charge Q is pulled at a constant speed with a constant force F from the negative plate all the way to the positive plate. Using the definition for electric field strength and the concept of work done, show that the magnitude of the electric field strength E is given by the equation E equals V upon D. So what we have is work done on charge is equal to energy transformed. That is what we know. Then work done is equal to force into distance, W equals Fd. Then energy transformed is equal to VQ. That then work done is equal to Fd is equal to VQ. Then from that we can obtain electric field strength. F upon Q is force over charges. We discussed that earlier. F upon Q is equal to Q, therefore it is equal to Vd, and that we have proved that. Then two parallel metal plates, the second question, two parallel metal plates separated by 2 centimeters have a potential difference of 5 kilovolts. Calculate the electric field force acting on a dust particle between the plates that has a charge of 8 into 10 to the power 19 coulombs. So we have to obtain the values, we have to take the values in their units, right? So 2 centimeters, we have to convert that into meters. Then the separation is 2 into 10 to the power minus 2 meters. Then the voltage they have given in 5 kilovolts, you multiply that by 1000, so 5 into 10 to the power 3 volts. And then the Q, charge, is given in coulombs, therefore you can write it as it is. Then after we have turned all of them into base units, we have to calculate the force F by taking the appropriate equation. But we cannot calculate the force directly. We have to find E. Then what we do is we use the equation E equals V upon D, and then we get 5 into 10 to the power 3 divided by 2 into 10 to the power minus 2. That gives us 2.5 into 10 to the power 5 volts per meter. Then we have the equation F equals EQ. Then when we substitute to that, it gives us 2 into 10 to the power minus 13 newtons. I hope you understood. If you did not understand any part of this, please ask questions. After you are done with it, you will have to do the questions from 4 to 8. But before that, let me give you the note so that you have this to refer. Write down electrical field strength. Electric field strength. Take a different colored pen and write down the definition. Electric field strength at a point is the force per unit charge. Is the force per unit charge exerted on a stationary positive charge at that point. Force per unit charge exerted on a stationary positive charge at that point. And then please draw this 21.10 diagram. Then you will understand this. Leave a line and write after drawing. From the definition, we can obtain the equation E equals F upon Q. Then from that you can take equations for Q and F both. Then F is equal to EQ, Q is equal to F upon E. Right? So you remember E equals F upon Q, then you will understand the rest of it. Leave a line and write. From the equation, E will have units newtons per coulomb, NC minus 1. Leave a line and write. When two parallel metal plates are connected by a high voltage power supply, the strength of the field will depend on two factors. Number one, the voltage V between the plates. Put a dash and write. Higher the voltage, higher would be the field, or stronger would be the field. E is directly proportional to V. Number two, the separation D between the plates. Put a dash and write. Greater the separation, weaker is the field. So then E is proportional to 1 upon D. By combining, leave a line and write, by combining, we get another equation for E. E equals negative V upon D. E equals negative V upon D. However, when studied, we realize that E is equal to, the E is the electric field, is equal to change in potential divided by the change in distance. Leave a line and write. This gives us the equation E equals negative delta V upon delta D. Negative delta V upon delta D. Put a star and write down. We usually omit the negative sign because we are mostly concerned about the magnitude of the field strength. From this equation, another line, from this equation, we can get another unit for E, which is Vm minus 1 volts per meter. I hope you understood. If you did not understand, please ask me questions. And please do the questions 4 to 8.